Good morning, grade 10 STE. So our topic is about moving plates and the changing earth. Our learning competency is A. Describe and relate the distribution of active volcanoes, earthquake epicenters, and major mountain belts to plate tectonic theory. Letter B. Describe the different types of plate boundaries. Letter C. Explain the different processes that occur along the lithosphere boundaries. Earth's lithosphere is composed of various layers. The first layer is the crust. So the crust, it is the outermost layer of the earth where almost all life forms thrive, wherein kita nagakabuhi. So the crust is like the shell of a hard-boiled egg. And it is extremely thin, cold, and brittle compared to what lies below it. The crust is made up of relatively light elements, especially the silica, aluminum, and the oxygen. And this layer is composed of tectonic plates that hold the countries and the other continents together. As you can see, the planet Earth is like an egg. So the crust is like the shell of an egg. The mantle is like the egg white of an egg. Then the core is like the egg yolk of an egg. Tectonic plate. So the tectonic plate, it undergoes continental drift, which primarily responsible for the formation of different features of the plates. Tectonic plate movement caused the collision of some continental plates. When we say the collision, it is the eventual movement of the plate. So as the plates collide, energy is transferred from plate from one another that results to an earthquake. After the collision, one plate may fold edges, slide over the other, go under the other plate, that lead to the formation of the landforms, as you can see in the GIF. Next is the earth mechanism of tectonic plate. So the theory of plate tectonic attributes the various events such as earthquakes, volcanoes, mountain building processes, and other phenomena related to motion. There are two major. It's number 2. There are two major thoughts that were raised to explain the mechanism of plate tectonic. The mantle, it's not mantle. The mantle convection theory and the slab pole theory. First, mantle convection theory. So this theory states that the fluid expand and become less dense when heated. And it was proposed by Arthur Holmes in 1929. And he added that when the material cools, it would sink. According to Holmes, the pressure of the heated magma broke the continents apart, forcing the pieces to drift in opposite direction. Next is the slab pole theory. So this theory states that the gravity and the plates themselves are the one responsible for the plate tectonics through the subduction process. So the second layer of the earth is mantle. So at close to 3,000 kilometers, 1,865 miles thick, this is the earth's thickest layer and made mostly of iron, magnesium, and silicon. It is dense, hot, and semi-solid like the caramel candy. So the mantle's temperature reaches the melting point of rock. The continental drift is said to be due to the fluid motion of the mantle, as you can see in this GIF. So next is the continental drift. So the continental drift, such movement is due to the convection of current generated within the mantle as the result of the heat coming from the planet's core. Plate's core rather. Next is the inner core. So the core, we have two layers, the inner core and the outer core and the inner core. First is the inner core. So this solid metal ball has a radius of 1,220 kilometers or 758 miles, or about 3/4 that one of the moon. And it is extremely dense. It's made mostly of iron and nickel. So the inner core spins a bit faster than the rest of the planet. It also intensely hot, as you can see in this GIF. So mas madasigid man ang paglibot sa inner core. So the outer core. So the outer core made from iron and nickel just in liquid form. So sets from 5,100 to 2,880 kilometers or 3,220 to 1,700 miles below the surface. So heated largely by the radioactive decay of the elements uranium and thorium, this liquid joins in huge turbulent currents. So they in turn generate Earth's magnetic field. So this is the layers of the Earth. First is the crust, mantle, outer core, and the inner core. So let's summarize the layers of the Earth: the crust, the mantle, the outer core, and the inner core. So this is the illustration para makita yung gid ang kada isa. So first is the crust, the mantle, the outer core, and the pinakagamay is the inner core. So next is the mountain ranges. So the mountain range is a group or chain of mountains that are close together. So they are usually separated from other mountain ranges by the passes and rivers. This is the example of mountain ranges. So the orogeny, it is the events that lead to the deformation of large part of Earth lithosphere to create the mountain. So that is, ang tawag sina is the orogeny. So what is the highest mountain range in the world? So the Himalayas are the highest mountain range in the world. So, as you can see in the picture, that is the Himalayas. So, the summit of Mount Everest at 29,335 feet or 8,850 meters is the highest point on Earth. So, amoy na kataas ang Mount Everest nga makita sa may Himalayas. How are mountain ranges formed? So according to tectonic plate, when one enormous plate of Earth crust began diving beneath another. Number 2, as the plate comes together, the continental plate becomes riddled with faults. So the thickening crust continues to push the rock into air. Then the overlithosphere bob higher, raising the plateau. As the sediments wash off the high, it builds up into rocks layer. So that is the how to form the mountain ranges. The different mountain ranges. So first is Himalayas, the highest mountain range in the world. So the Himalayas strength is 1,491 miles through much of Central Asia. Next is the Andes, the longest mountain range in the world. At around 4,300 miles long, and Andes Mountain make up the world's longest mountain range. So that is the example. So Alps, largest mountain system in Europe. The Alps are the major mountain range in the Central Europe. They pass through many European countries including France, Germany, Switzerland, Italy, Austria, and Slovenia. Next is the Rockies, the major mountain range in western North America. So the Rocky Mountain range from north to south in western North America. They run from the Canada to the US state of New Mexico. So that is the Rockies. Next is the Appalachian, the oldest mountain range in the United States. So the Appalachian Mountains are parallel to the Atlantic Ocean coastline on the eastern part of United States. Next is how are volcanoes formed? Kulang. So volcano, it is a mountain that opens downward to reservoir rock called the magma. So volcano formation via plate tectonics. So portion of solid plate melt and form magma from the extreme pressure and heat in the mantle. Next is magma rises to the surface of the earth to release its heat and pressure. Plates collide and compress with each other. Compressive forces between plates cause the plates to slide over the other. Next is the tectonic plates move and float on the mantle. So classification of volcano. So the active volcano, they have connection between its crater and magma source from the innermost layers of the earth, resulting in relatively frequent eruption. Then is inactive volcano, connected to its magma source but erupted during the past 10,000 years ago. Then that is the example of inactive volcano. The Mount Bagakay is mountain and it is located in the province of Camarines Norte, Bicol, Philippines. The elevation above sea level is 7,887 meters. So the extinct volcano, one whose magma is supply is cut short. So earthquakes in the epicenter. So how earthquakes are formed? First is tectonic plates move slowly reef on the surface due to the convection currents underneath. So plate collides as they move on the surface of Earth. Then after that, collision of tectonic plates results in ground vibration or earthquakes. Faults appear upon collision of tectonic plates. Then it is the earthquake. It is a natural phenomenon that is characterized by the sudden violent shifting of massive plates underneath the Earth's surface. So it is a form of wave energy that are transmitted through bedrock. So as you can see in the picture. So the focus within the Earth along the geologic faults wherein the earthquake originates. So sa idalom ina siya ang focus. So the epicenter points wherein the Earth's surface directly above the focus. So amo nang kinaiba sa idalom ang focus, ang epicenter sa ibabaw. The surface ang epicenter. Then fault, it is across which rock have been offset first. So then classification of faults. First is the normal fault, a fault in which hanging walls move down relatively to the footwall as a result of extension. The example of that is Cabrillo fault. Next is the reverse fault. First fault is a fault in which hanging walls move up relative to the footwall as a result of compression. Example of that is Sumatra earthquake fault in 2004. And then strike, slip fault. Two blocks of grass slide past each other on the same plate. So that's it. Thank you, grade 10. See you again. Bye.